We know that the rumen destroys most of the vitamin A it encounters, but there's so much of it going in, so much beta carotene going in, that enough bypasses the rumen or escapes destruction in the rumen that we can still have enough to keep the animal healthy. When we're looking at the requirement, I'm not going to ask you to remember those. I probably should go back and see if they changed those in the last year. But growing animals require 80 IUs. They are international units. So there's a standardization among vitamins because they all have different atomic weights and things like that. You're trying to deal with an active unit of that vitamin. So 80 IUs, international units, per kilogram of body weight. Mature cows lactating dry, 110 IUs per kilogram of body weight. So we're looking at, up at the dairy, if we've got a 500 kilogram animal, we're looking at like 5,000 international units a day. 6, 7 for our mature lactating animals is probably pretty standard. So we're dealing with hundreds of units for vitamin A. So this is the drawing made by my professor's daughter to help us remember what vitamin A does. And this was the spark that suggested that perhaps some of you might learn by doing something like this. I find some of the silliest associations I made as an undergrad have helped me remember things for a very long time. So we have A up there with the moon out. Needs those moon glasses to get through if they're doing the vitamin A. If they're not getting the vitamin A, there's going to be some problems. So one from a student. Vitamin A helps with vision. For starters, doctor says lay off the vitamin A. So vitamin A, eat Angus so you don't go blind. So there is a possibility that if you're on the rarer side with your meat, there might be in that marbling some vitamin A in that marbling. So don't go blind, eat beef. You got any vitamin A? The liver says, yep, I got some stored in the liver. Vitamin D. Vitamin D is associated or related to calcium absorption, which is the calcium going from the diet through the gut into the body, and then resorption, which is taking the calcium back out of the bone. So moving that calcium around, those two things will help increase blood calcium concentrations. Every few years, there's a company that says, well, we're going to fix milk fever by feeding more vitamin D, and it never works. There's going to be a time when it does. We figure out exactly what's happening, exactly what's there. But for the short run, that extra vitamin D to our transition cows hasn't helped prevent milk fever yet. But I think sometime we will figure it out and figure out how to give it and provide it in such a way that things get taken care of. Vitamin D is necessary for all the things that calcium does. So mineral metabolism in the body and bone growth. We need vitamin D to make that happen. So that's why everybody read the ingredients on a gallon of milk. The ingredients list on a gallon of milk. milk and vitamin D. So the idea is the calcium is right there. We should enhance the absorption with vitamin D. Now, I've heard recently, and I have to follow up on this, that there's some school of thought that says that doesn't work, which doesn't make any sense to me, but I'm willing to learn if somebody's going to teach me something new. So we need that vitamin D for growth. Thing about vitamin E is we can overdo it. So we have to be careful. So we're dealing with deficiency versus toxicity. If we don't have enough vitamin D, we're going to get poor bone mineralization. We're going to get soft bones. Those bones are going to bend, especially in the younger animals. That's called rickets. We get the bow legs associated with rickets. Not excessive horseback riding, but just we don't have enough calcium. We got protein there. We got the matrix that is the shape of the bone, but we don't have enough calcium in there to make it solid, to make it rigid. So vitamin D fosters that calcium absorption, pulls stuff out of the bone, providing calcium to hopefully do what needs to be done. Osteomalacia is one of the two things we see where the bones are starting to become brittle and easily breakable. Osteoporosis, osteomalacia. For the purposes of this class, they're essentially the same, but I took minerals and vitamins. We talked for at least a half a lecture on what the difference was between the two. Osteomalacia in the mature animals. If we overdo it with the vitamin D, we get toxicity signs that include the calcification of soft tissue. So calcification of soft tissue is going to do what to that tissue? What happens if we calcify the bones? Soft tissue different than the bones. The more calcium we put in the bones, what do we get happening? Those things get more rigid, more hard. If we start getting too much calcium in the body doesn't know where to put it. It starts putting it into soft tissue, organs, muscle. What happens if your heart goes rigid? It would basically ruin your afternoon, right? If your guts become rigid, calcified, they're not going to work anymore. The function of them to being able to move and twist and all that stuff is essential. So we want to make sure we don't overdo it with our vitamin D. So we have on the left there, we've got a vitamin D deficiency. The animal has rickets. Those bones are no longer rigid. They're no longer able to hold the animal upright. So they're going to flop in one way or another. And then the muscles are going to be what holds up the legs, not the bone. Sort of like a bow and arrow. You get the rigidity with the triangle. That's trying to form a triangle that allows that to happen. So on the right side, we have severe rickets from ration receiving deficient in vitamin D and without sunlight. So does anybody know the relationship between vitamin D and sunlight? It catalyzes the production of vitamin D. UV light hitting your skin will take the precursors in your body and generate vitamin D. So that's why vitamin D is called the sunshine vitamin. So one of the problems living up in the northern latitudes is you got times of the year where not only do you have a lot less sunlight, you also have very low intensity of that sunlight. I have a friend that lived in Fairbanks. He'd get an hour of sunlight a day, but he said it's like taking the last 30 minutes of the day, sticking it with the first 30 minutes of the day. You look at the southern horizon, the sun would go whoop, and that's it. So, of course, when it was minus 80, we used to call him up and laugh at him. But yeah, minus 80 is just wrong on so many levels. But that sunshine, so you're not getting the intensity of the sunlight. In some of the northern places, people have UV lights that will stimulate that vitamin D production. It's thought to be related to seasonal mood disorder. There's another word in there I'm missing. Seasonal mood disorders, that you're not getting enough vitamin D. So in January, you're just kind of like, well, I don't feel anything. So not only is your skin not exposed, but when you go out, you got everything covered up, right? So there's some thoughts that it enhances your mood if you can get that light. So I know some people around the breakfast table have that light bulb above the breakfast table to help in the wintertime when things are still dark out. So vitamin UV light hits the skin, catalyzes a precursor made from cholesterol to the vitamin 125. I think that's on the next slide here, metabolism. So you have a pro-hormone, a precursor. That cholesterol-based molecule has some modifications to it. Then when UV light hits the skin, it's catalyzed to vitamin D3 and vitamin D2. Those are the active forms that will influence the uptake of calcium. So that catalyst happens with UV light on the skin, or I guess anywhere, like if you can get UV light through. And the kidney will also involved in this transfer, this modification, this isomerization. So you're looking at 25 hydroxy polycalciferol or 125 dihydroxy cholecalciferol. That means there's a alcohol group, an OH hydroxide, stuck on the first carbon and stuck on the 25th carbon. So as we move from one to another. So made in the animal when she's exposed to sunlight. It's also made in the feed when that feed is exposed to the sunlight. So we think about hay down in the fields. The longer it sits out there, the higher the vitamin D will be. That's not practical or useful. We don't want to manage our hay by vitamin D content. But it is just a useful bit of trivia. So if a cow's out on pasture, do we have problems with vitamin A or vitamin D? No. They got more than enough green plants to consume. They got more than enough UV light on their skin to get what they need done. So requirement, if the animal is in the sun and on pasture, there's probably no extra needed. We think about a beef cow's on pasture, we don't routinely supplement vitamin D, except maybe in the winter. 70 IUs per kilogram of body weight. So we're down about 30% from where we were with vitamin A. Vitamin A, the largest active units, we're working our way down with vitamin D, and it doesn't really matter. So vitamin D is called the sunshine vitamin, so remembering there. So another version of that one, vitamin D from the sun, Holstein, vitamin D coming from the sun, forming in the skin of our Holstein. Sunny D. The kidney down there is where the vitamin is made. We've got vitamin D from the cow or the feed. And this is the drawing I dealt with. If we got the sun, we got good, strong, straight bones. If we don't, we've got rickets. So we'll stop there and continue on next time. Yeah, I suppose today is the last question day, is it not?
Yep.
Yep. If anybody needs forms to write their question on, we got extras.
Scheduling. I try to generate a schedule and it just tells me I can't. It just says this.
Those schedules are available, so take math 102 or COM 111 out. Actually, probably chemistry is what's messing you up the most. Why are you taking those for
I just have,
transfer or,
yeah.
okay? So one of those means that there's a overlap on those. So can you click on the individual?
Yeah, see it works in.
Okay, so you took the math out?
Yeah.
Okay.
So cool.
Okay. So one in math just overlaps probably with a dairy science or something. Yes.
For we have a dairy company tomorrow at
11?
11.
Okay,
Yeah,
where?
Somewhere in Marshall.
Okay,
Marshall, Dr. Marshall
okay.
created it. She wants to sign thank you cards.
What do we have to do to protect that? We need special paper.
Probably be nice if we had some nice paper. There might be some in the cabinet. See what I can find for paper. Okay.
Let her know.
Okay. Paper for thank yous. There might be some in the old cabinet there next to the student lounge. At least I saw some this morning that might work.
Are these guys working on the fixing line?
A little bit, yeah.
They got.
Not till the end, so probably 3 o'clock on. Probably gonna do some right now. But I'd rather you didn't bug them until lab.
Keep going.
Okay.
Thank you.
Yep.